How sustainable aviation fuel, so-called SAF, is made from used cooking oil. Hi everyone, welcome back to Everyday I Wonder. Today we're diving into an incredible innovation that's changing the future of air travel, sustainable aviation fuel, or SAF. Specifically, we'll explore how SAF is made from something as simple as used cooking oil. But first, let's start with the basics about jet fuel. What is jet fuel? Jet fuel is a type of petroleum-based fuel designed specifically for aircraft. It's made from refined crude oil and is known for its high energy content and stability under extreme conditions. The most common types of jet fuel are Jet A and Jet A1. These are kerosene-based fuels used in commercial aviation. They have a high flash point, making them safer for high-altitude use. JP8, a military-grade jet fuel with additional additives to prevent freezing and corrosion. Jet fuel is crucial for aviation, but its reliance on fossil fuels makes it a significant contributor to greenhouse gas emissions. This is where sustainable aviation fuel, SAF, comes in, offering a cleaner alternative. What is SAF? Sustainable aviation fuel, or SAF, is a type of jet fuel that's produced from renewable resources instead of fossil fuels. It's designed to reduce greenhouse gas emissions and help the aviation industry transition to a more sustainable future. One of the most promising feedstocks for SAF is used cooking oil. Yes, the oil left over from frying your favorite foods. Other feedstocks for SAF include animal fats, agricultural residues, municipal solid waste, algae, and dedicated energy crops such as camelina or switchgrass. How is SAF made from used cooking oil? The process of turning used cooking oil into SAF is complex and involves several precise stages to ensure the final product meets strict aviation standards. Here's a detailed breakdown. Step 1. Collection. Used cooking oil, short for UCO, is gathered from sources like restaurants, food processing facilities, and households. Efficient logistics systems are critical for collecting and transporting the oil to processing facilities. Step 2. Pretreatment. The UCO undergoes cleaning to remove impurities such as food particles, water, and other contaminants. Filtering, degumming, and drying ensure the oil is a pure feedstock for further processing. Step 3. Chemical procession, including hydrodeoxygenation, or HDO. Hydrogen is introduced to remove oxygen molecules from the oil. This step converts the oil into hydrocarbons similar to jet fuel. Hydrocracking. Larger molecules in the oil are broken down into smaller, more stable hydrocarbon chains, improving the fuel's energy content and stability. Isomerization. The molecular structure is further modified to enhance properties like freezing point, ensuring the fuel is suitable for high-altitude conditions. Step 4. Catalytic refining. Specialized catalysts refine the hydrocarbon chains further, ensuring they meet aviation fuel standards for energy density, viscosity, and combustion characteristics. Step 5. Separation and purification. The refined fuel is separated into different fractions, isolating the SAF fraction and removing any residual impurities. Step 6. Blending. SAF is typically blended with conventional fossil-based jet fuel, up to 50%, to meet existing aviation requirements and ensure compatibility with current aircraft engines. Step 7. Quality testing. The final product undergoes stringent quality testing to ensure it meets global aviation fuel standards, such as ASTM 7566. Tests include checks for energy content, freezing point, flash point, and overall performance. Step 8. Distribution. Once certified, the SAF is transported to airports and blended into the fuel supply for use in commercial and cargo flights. Benefits of SAF from used cooking oil. Making SAF from used cooking oil offers numerous advantages such as lower carbon emissions. SAF can reduce life cycle greenhouse gas emissions by up to 80%. Circular economy. Recycling used cooking oil reduces waste and promotes a more sustainable system. Compatibility. SAF can be blended with conventional jet fuel without requiring engine modifications. Scalability. With the right infrastructure, the production of SAF from UCO can be scaled to meet growing aviation demands. Challenges in SAF production. While promising, producing SAF from used cooking oil has its challenges. Supply limitations. The availability of used cooking oil is finite and may not meet the global aviation demand. Processing costs. The production process is more expensive than refining fossil fuels. Logistics. Collecting and transporting used cooking oil on a large scale can be complex. So, the next time you think of discarded cooking oil, remember, it could help power the planes of tomorrow. Thanks for watching Every Day I Wonder. Don't forget to like, share, and subscribe for more everyday science made simple.